Hello everybody, this video is a continuation in a series on land navigation. I'd first like to caution that if portions of this video are at all unclear, I'd highly recommend that you go back and review part 1. And I'll say it again, while the point of this series is to produce a very complete overview, it still is not a substitute for real hands-on training. Always seek safe hands-on land navigation training from a capable instructor. Okay, let's jump right on in. Recall that in part 1 we talked about these numbers here in the top and side margins of our map. We also talked about how these numbers were derived and that this number here represented the distance in kilometers from the equator northward to this horizontal grid line here, and also that this number over here represented the distance in kilometers from this particular zone's central meridian to this vertical grid line here. Okay, let's now take a closer look at these multiple size numbers. Again, we know how they were derived and what they're measuring, yes, but when we start to plot more complex positions on a map within these major grid lines, the notation system that you use to represent your location can sometimes get a little cluttered, and that in turn can make land navigation harder for you. Now, to demonstrate this last point, here is a fully notated grid coordinate. A little complicated if you ask me. So just how can we simplify things here? Now, before we start to simplify things, let me make perfectly clear here that the place value abbreviations that I'm about to show you hold true for large scale maps, such as a 7.5 minute 1 to 24,000 scale map, which is by far the U.S. Geological Survey's most common map. However, these conversions will not hold true for smaller scale maps, which can be in scales of 1 to 100,000, for instance. I just wanted to establish that before we get calculating. Okay, let's go ahead and begin. Now, when you and other team members are working in a group and sharing the same local map in the same general area, it's really not necessary to notate all the numerical place values that you see here. Because you're working a large-scale map in a very localized area, you can instead only notate the place values that are most relevant to the size of your immediate area. Let me put it another way. It's like going to a drive-thru and you're about to order, and you say, I want a delicious, hearty, tasty, satisfying burger with pasteurized American cheese and farm-grown lettuce. The guy taking the order is going to say, hey, buddy, you don't have to give me a big, long speech. What you want is plate number 5. You see my point? To get what you need, all you need to say is, plate number 5, please, and all the other extra verbiage you can cut out. The same holds true with coordinates. In a localized area, you can be just as accurate with only about half of the information that you see here. For example, it's not really necessary to notate the UTM zone. Everybody in your local area already knows what zone you're in, so you can drop this. Same thing with a 1,000 kilometer place value. It represents gigantic units of 1,000 square kilometers. Not really relevant or applicable to an area of, say, 10 or 20 square kilometers that you're patrolling on foot, so you can drop this as well. Same for the 100 kilometer place value. For localized areas of operation, it only clutters up the coordinates, so drop it. Now, the 10K place value you can keep. It's a small enough denomination to be relevant to your localized map. The 1,000 meter place value is likewise a definite keeper. That is, it's very useful to locate 1 kilometer grid squares on your localized map. Now, once we cross the decimal point here, we're getting into very small place values, and they're all good for increased accuracy. The 100 meter is an extremely useful place value, especially for a foot patroller. Definitely keep it. Same for the 10 meter place value. Extremely useful. Keep it. As far as the 1 meter place value, it may seem useful, but I have my reservations. Unless I'm burying a cache for later retrieval and have to be very precise down to the 1 square meter place value, I just omit it. For me, it unnecessarily clutters the coordinate. For everyday operations, the 10 meter place value here is the perfect sweet spot for generalized accuracy. Again, I just omit the 1 meter place value and only bring it back when I need pinpoint accuracy. So there you go. This is your finished product in the correct relevant place value denominations for in-close fighting or foot patrolling. Now, let's format this number for even easier reading. We can further clean this up by dropping the decimal, meters unit, and easting designator like this. And with both easting and northing, it looks something like this. I know it looks a little weird, but that's what abbreviations are for, and it'll make more sense as we go along. Let me give you an example, though. My wife and I took an incredible land navigation course about a year ago, and it was out in a pristine forest and very challenging. I took this photo of my wife at the head of the classroom. Sorry about that, honey. But what I really wanted to show you were the coordinates that we were issued here on the whiteboard. Take a closer look now. They're all abbreviated. Some are spread out like this, and others are scrunched in. But it didn't matter, since everyone in the class knew exactly what these sets of numbers signified. And by the end of this video, you will too. Again, this is a cleaned up and useful abbreviation, and it's a lot easier to read and work with while on the ground. Now, folks, I want to ask you, would you rather work with this number over here or this number here? Because truth be told, they both represent the exact same spot on your map. Let me say that again. These two coordinates represent the exact same spot on your map. Like I said, this format here is cleaner and easier to work with. And one last thing, unless otherwise specified, our coordinates will always begin in the 10K meter place value, right here. And then from here, we can add place value denominations to the right, depending on how accurate we want to get. Okay, I want to show you a 1 kilometer grid square on the map. And if I want to do that, I better include the 1 kilometer place value denomination. So let's do that right now. Okay, good, that helps. But this is only for the easting. A complete grid coordinate has both easting and northing, or both the x-axis and the y-axis. So let's add a northing. Excellent. Now, it's important to note here that both the easting and northing here end in the same place value denomination, which is the 1 kilometer place value. That's very crucial. Now, let's go find this 1 kilometer square on an actual map. When determining a grid coordinate, we first plot eastward, working from left to right in this manner. Afterwards, we then plot northward, working from bottom to top in this manner. Let me repeat that. When we plot, we first work from left to right and then from bottom to top. So let's go ahead and do that. And here we are. Remember I said that our coordinates will always begin in the 10K meter place value? Well, looky here. All the large numbers in the bottom margins do as well. They all begin in the 10K place value. And there's our match. Okay, let's now plot upward. And here we are. And look here again. The same applies to the side margin numbers. And just like our grid coordinate, all the large numbers on the side margin begin in the 10K meter place value as well. And here's our plot, 47 kilometers easting by 78 kilometers northing. This kind of place value matching makes finding 1 kilometer grid squares extremely easy. It's also important to note that when you have a combined 4-number coordinate, that is 2 numerals in the easting and 2 numerals in the northing, it's technically termed a 4-digit grid coordinate. And a 4-digit grid coordinate in a 7.5 minute 1 to 24,000 map always renders a 1 square kilometer grid plot. And don't worry about map types so much right now. We're going to cover that in part 3. For now, focus on plotting coordinates. Now, a 6-digit grid coordinate would simply add one more number to both the easting and northing in the 100 meter place value. And here it is. And as the place value likewise indicates, we'll be zeroing in on a 100 square meter area on the map. Now let's go plot this thing. It's super simple, you see, since we already know the 1 kilometer square we're in. Remember? Left to right. And here's 47. And now bottom to top. There's 78. Okay, we're now in the 1 kilometer square grid. We now need to measure within this grid and essentially find the 100 meter square. So would you please say hello to my little friend? This is a 1 kilometer UTM grid, and it further subdivides a 1 kilometer square into 100 meter squares, as you see here. Let me tell you, this little guy is a 6-digit grid coordinates best friend. Now, I took the liberty of taping it onto my computer screen in order to give you all a hands-on view, and I had to adjust the zoom a bit, but I got it pretty close. Okay, let's measure this guy. 0, 1, 2, 3. That takes care of the easting. Now the northing. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that takes care of the northing. Now we know that this grid coordinate has something to do with this pond here. By the way, this is a 1965 1 to 25,000 map of Camp Bullis, Texas. Some veterans watching this might have even been on this very spot. Okay, so that's a 6-digit grid coordinate. Now, if we wanted to get even more accurate than this, we can plot down to a 10-meter square. And to do this, you would need, you guessed it, an 8-digit grid coordinates. And as I said, it would get us down to a 10-meter square accuracy. Okay, let's plot it. Well, we already know that we're in this 6-digit coordinate, or 100-meter square. We just need another type of protractor to measure in tiny 10-meter increments. And so here's my other little friend. It's like the military protractor that we all use, but it's been improved. It has both 1 to 24,000 and 1 to 25,000 scales, and it's only 2 3/4 inches all around. Very neat design, durable, and not too cumbersome. These are available at maptools.com, and tell John that Analytical Survival sent you. Okay, let's plot this thing. We're going to align the bottom scale with the grid square and slowly slide the protractor to the right until the number 34 aligns perfectly with the left border of the grid. And it should look like this. Once the bottom scale is locked into 34, turn to the vertical scale, and now we're going to lock in 91 on the vertical, which would be right here. Now make sure to place your mark in the center of the slot. Okay, it looks like we're on the southern side of this pond, right up against the western slope of a hillside and right above the fork of 2 intermittent streams, and sitting in the middle of a 10-meter square. Okay, that's it for part 2. Stay tuned for part 3, where we'll discuss the following topics in depth: representative fraction and scale, military grid reference system, or MGRS, map types and scales, and plotting grid azimuths. This is Analytical Survival saying stay safe, my brothers and sisters.